Hello friends, welcome to Susan and John MathTube. This is lesson number 5 in Laplace Transform. And as always, the most important question and of course the 5 important points. So let's start. And as always, I want you to read all the formulae before we continue. And this lesson is very important because we are going to do a few problems which they ask regularly in the exam. I told you in the last video, the problem which they ask in Laplace Transform, they will ask in two small parts. They will ask two simple questions and together it will be 5 marks. Anyway, everything depends on the 3 properties. And this is exactly what we are going to do in lesson number 5 and lesson number 6. So, you're supposed to know all the formulae. Actually, this line implies you know all the standard formulae. That means you know the Laplace of the standard functions. For example, you know the Laplace of sine 5t. You know the Laplace of e power 2t. You know the Laplace of e power minus t. Okay, so you're ready with all the Laplace of simple functions. And even we learned how to find the Laplace of sine square t, cos square t, sine cube t, etc. So that is what we did in lesson number 3 and 4. We learned to calculate the Laplace of many functions. Now we are going to extend this with the shifting property. And the job is really easy. So if you want the Laplace of the same function multiplied by e power 80, all you have to do is replace this s with s minus a. So graphically there will be a shift in the graph. Okay, now suppose you want to multiply this function by t or t square or t cube. All you have to do is differentiate this as many times n is, like for example, if it is t square, you have to differentiate 2 times. And by the way, don't forget to multiply by minus 1 to the power n. And the third property, that is division of t. Suppose you know the Laplace of some function and you want to find the Laplace of that same function divided by t. So you have to evaluate this improper integral and get the answer. Please write the first question. Find the Laplace transform of e power 2t into cos t. Okay, so what I'm going to do is, I'm going to write Laplace of cos t because I know the Laplace of cos t. What is the Laplace of cos t? I hope you don't want the formula. Anyway, I'll display it here. Okay, so what is Laplace of cos t? And this is equal to, it starts with c, so it starts with s by s square plus 1. Okay, now I'm going to write the Laplace of the same function. I'm going to write the Laplace of the same function multiplied by, look at the question, e to the power 2t. Okay, I'll take a sneak peek at the property. If you multiply by e to the power 80, what should we do? Yeah, you have to replace s with s minus a. Okay, so I'll circle that s for you. So the answer is s minus 2 by s minus 2 the whole square plus 1. And that's it. Now you can simplify s minus 2 by s square minus 2 into 2 4s plus 4 plus 1 5. That's it. Now let's make it a little bit more complicated. Find the Laplace of e power minus 3t multiplied by sine square t. So what should I do? I have to start with this. So I'm going to write Laplace of sine square t. Now you might understand the importance of lesson 3 and lesson 4. We learned how to evaluate Laplace of many functions in lesson 3 and 4. And one of course was sine square t. Anyway, I'll write the formula for your advantage. Sine square theta will be 1 by 2, 1 minus, tell me please, 1 minus what? 1 minus cos double the angle. And that means this will be equal to Laplace of 1 by 2, 1 minus cos double that angle. And this will be 1 by 2, and the remaining part will be Laplace of 1 minus Laplace of cos 2t, and that will be 1 by 2, that will be 1 by s, and this is cos means it starts with s, by s square plus 4. Now you can simplify this a little bit. So we get Laplace of sine square t is equal to, okay, let's go for LCM. So 1 by 2 s square plus 4 minus s square the whole divided by s into s square plus 4. So this will get cancelled, and we end up with Laplace of sine square t is equal to 1 by 2. Okay, so that will get cancelled. So 2 divided by s into s square plus 4. So right now I didn't teach you anything new. We learned this. We already learned this in lesson number 3. Now comes the advantage of the properties we learned right now in lesson 5. Okay, so I'll show you the properties. If you know the Laplace of any function, and if you multiply that by e power at, then what should we do? Shift it. That is s minus a. Okay, so I'm going to apply that. I know the Laplace of sine square t, but I'm asked to find the Laplace of e power minus 3t into sine square t. So I'm going to write that Laplace of, I'm going to write the same thing because the property is like that. You can find the Laplace of the same function multiplied by e power at. But who is instead of a here? Minus 3. So I'll circle s for your advantage, and the answer is 2 divided by s minus, that means s plus 3, and then s plus 3 the whole square plus 4. Now expand, simplify, etc., etc., etc. Okay, now let's do one more problem in the same group. Find the Laplace of cos t into sine 2t. So what are we trying to find? Laplace of cos t into sine 2t. This will be equal to Laplace of, what is cos? E power t plus e to the power minus t the whole divided by 2 multiplied by sine 2t, and that will be Laplace of, okay, this 1 by 2 will come outside, and then e power t plus e power minus t into sine 2t. Now let's distribute this. Let's open the bracket and distribute this. So we get 1 by 2 Laplace of, okay, I'll give some coloring for you, e power t sine 2t plus e power minus t sine 2t. Okay, I think from that coloring itself you understood what I'm going to do in the next page. So this is equal to 1 by 2 Laplace of, now I'm going to apply linearity property, e power t and sine 2t plus 1 by 2 Laplace of, because this 1 by 2 will also split and Laplace will also split, e power minus t into sine 2t. Okay, now look at this. On one corner, I am going to write the formula Laplace of sine 2t. It's a standard formula. Now I am not going to display that screen. I am sure you know the formula. What's the formula? Yeah, so s, it won't start with s. So 2 by s square plus 4. Isn't it? Okay, now what I am going to do is I am going to circle this, because in this lesson what we learned is, if you know the Laplace transform of a function, then you can obtain the Laplace transform of the function multiplied by e power t, or e power 2t, or e power 3t, or e power minus 2t. And what is that property? Oh, you have to replace s with s minus a. So that's why I am circling that s. So our answer is ready. 1 by 2. So what will be the answer? It will be the same thing, but it's like 2 by s minus 1 the whole square plus 4. What is the reason I replaced s with s minus 1? Because the coefficient of t is 1. Now the second one is waiting for us. So it's also the same thing, 2 by, but what is the coefficient of t? Yeah, so s plus 1 the whole square plus 4. I hope you understood that, but in the exam you should not leave like this. You should take LCM and put it in proper form, simplify as much as you can for the exam. Okay, now let's go for another question, and that is Laplace of t square into e power minus 2t. Okay, actually we have property for e to the power and multiplication with t to the power 2. Multiplication with t to the power tells you have to differentiate 2 times. What should you do? You have to differentiate 2 times. And the property of e to the power simply says replace s with s plus 2, because it is actually minus 2 over here. Okay. So you are allowed to apply any method you like. Anyway, I don't feel like differentiating now. So I am going to write Laplace of t square first. So I chose t square here. So what is Laplace of t square? 2 factorial by s to the power 2 plus 1. Okay, so that means you know the Laplace of t square. Now look at this. I am going to write Laplace of the same function. I am going to write the same thing, but multiplied by the character e to the power minus 2t. A into b and b into a is the same. So what I did is I found the Laplace of t square, and I have a property where I can multiply the same function to e power minus 2t. So what will be the answer? 2 factorial is 2 by s plus 2 the whole cube. I hope you understood that. Okay, now another question. Find the Laplace of t square into sine t. So what are we going to find? We are going to find the Laplace of t square into sine t. So I am going to write something that will be an advantage for you. T into sine t. It looks silly, but it means a lot. First this, then this, and finally this. Okay, once more I wanted to show the property page. Look at this. If you know the Laplace of any function, you can have the Laplace of that same function multiplied by e power at. What should we do? S must be replaced with s minus a. If you multiply by t to the power n, you have to differentiate n number of times that function, but don't forget to multiply by minus 1 to the power n. Anyway, in this problem, I am going to apply property number 2. So let's start. So I'm going to write, we have Laplace of, look at the innermost part, sine t. So Laplace of sine t, you already know. It is s here, so it won't start. So 1 by s square plus 1. Now what I do is, I write the same thing, but I will multiply by t. Yeah, I know, we have to multiply by t square, but I'm going to do it step by step. So when I multiply by t to the power 1, the property which I showed you tells me you have to differentiate it once. How many times? Once. But don't forget minus 1 to the power 1. And that will be equal to minus. So tell me, what is the derivative of 1 by x? Derivative of 1 by x is minus 1 by x square. And what's the derivative of 1 by something? A smiley. It will be minus 1 by that smiley square. No, that's not enough. Multiplied by the derivative of the smiley. Says who? Yeah, says chain rule. So don't forget that. I've seen in the exam many students forgetting this second part. So once more I'm asking, what is the derivative of 1 by x minus 1 by x square? So we are going to differentiate 1 by something. This is our smiley. So minus 1 by same thing squared. Multiplied by 2s plus 0. Wait a minute, we had one negative outside, right? Minus on the whole power 1. So this will be plus. I hope you understood that. Okay, anyway, I'm going to write that is Laplace of t into sine t. That is what we found here, right? What's the final answer? Yeah, 2s by s square plus 1 the whole square. And I hope you're okay with differentiation. Okay, now take a look at the question. We want t square. Oh, look at this. I know the Laplace of t into sine t. What do I know? I know the Laplace of t into sine t. So what will be the Laplace of t into sine t? Look at this. We are allowed to multiply any function by t. All you have to do is put minus 1 to the power 1 and differentiate the answer. So I can see s in numerator and denominator, and that calls for the quotient rule. I hope you remember all these things from your high school level. So denominator square I will write now itself. So denominator and derivative of the numerator minus numerator and derivative of the denominator, that will be 2 into s square plus 1 into 2. Okay, now it's your turn. Simplify, 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 and you will get the answer. I hope you understood this problem. Okay, now let's do one more question which I've seen in many question papers. That is Laplace of t into e to the power minus t into sine t. So the technique is same. We will do the method which we did earlier. So we'll start from here. Laplace of sine t. Now I am sure that you are all experts in formulae. S means it will not start with s. 1 by s square plus 1. Now I am going to write the same thing. I am going to write the same thing, but I am going to multiply this by t. If you want, you can multiply by e power minus t, or if you want, you can multiply by t. Anyway, I am going to multiply by t because I am in a good mood to differentiate. What is the property of t power 1? You write minus 1 to the power 1 and d by ds, you have to differentiate 1, the above function. That will be minus this minus 1 by something. What is the derivative of 1 by x? Minus 1 by x square. So we get s square plus 1 the whole square times y times, because it is not 1 by x, it is 1 by something, and chain rule tells you to differentiate this. Okay, so what we just found is Laplace of t into sine t is equal to 2s the whole divided by s square plus 1 the whole square. Now I am going to write the same thing. Look at this, I am going to write the same thing, but I have to multiply by e power minus t. That's it. Now we created the question. I hope you understood the trick. Okay, and the property of e power tells me I should circle this s, not in your exam paper but inside your brain, and replace s with s plus 1. So the answer will be 2 into s plus 1 by s plus 1 the whole square plus 1 the whole square. That's it. So I'll be back with more questions which they have asked in the exam. And as always, if you like the video, please share and subscribe, and we'll meet soon. So till then, my friends, bye.